There we go. All right. So we're going to look at the proxy pattern. What does the pattern give us? And then we're going to look at specific types of the proxy pattern, because we use these patterns probably more than we realize. So the proxy pattern is a structural design pattern, and it basically gives us a placeholder to access another object and deal with that object in different ways. Your format for the pattern typically comes in this way, where you have an iProvider. So you have your interface, you have the abstraction, then you have the concrete implementation, and then you'll have a client that needs to access that real provider. But you also have that client who will access the proxy. Now, when the client needs to access the real provider, it'll pass that real provider over to the proxy, and then the proxy will then call these things for like do stuff, or as we'll see, we have different demos calling different functions with actually more meaningful names. But this is the no tricks up my sleeve, nothing special to know about the proxy pattern. It has the same pattern over and over. It's just what kind of functionality can you do with it? All right. So we're going to look at a few different proxy types today. We're going to talk about the remote proxy. This one is probably one of the more common ones that we use, just don't think about. There's a virtual proxy, the cache proxy, the smart proxy, and then the synchronization proxy. So we're going to look at 5 different proxies, their different purposes, and then I also have a code sample for each of them that you can see. Now, if we run out of time for some reason and we don't get to all of them, rest assured the demos for each one of these proxies is within one repo. So you'll see that in the thank you email after this. And then for those who are watching this on YouTube long after the delivery, if you want that thank you email, we'll make sure to put a note in the description on how you can get that. All right, so let's talk about remote proxies. This is the first of the proxy pattern implementations that I want to point out. And what it's used for, so think of it as you're dealing with a remote object. And so this allows you to deal with communication, marshaling and unmarshaling, and then looking at local and remote responses. So let's take a look at what this means. For remote proxies, you're going to see this with distributed systems. In a distributed system, you're going to access something that lives on a remote server, so you might need to make fewer calls, or maybe that thing is heavy, so you might want to make fewer calls and work with a cache proxy as well. We also have web services. So remote proxies, you're going to notice that there's communication going on of some sort, whether it's within a distributed system, or we're talking about maybe just making calls to an API, so interacting with web services. You probably have an HTTP client that helps with that. Another remote proxy application is with network communication. And then finally, for remote resource management. So the example that I want to show you is using a weather service. It's going to look like this. So we've got our iWeather service implementation. Or not implementation, we have the iWeather service, so that's our iProvider. Your real weather service, this is the actual implementation. Then we have our client that wants to get the weather. It knows about the real weather service, but it needs to use the proxy. The proxy then will take care of the handling of this. So this is our remote proxy. And what does this look like in code? So let's drop straight over to the code. So I'm going to open up my Visual Studio. And we'll get our Visual Studio open. All demos. I'm going to bring it over here where we can see it. Okay. Collapse all descendants, close all my proxy demos. We want to look specifically at remote. And as I mentioned with that class diagram, we have the interfaces. So I have this iWeather service. Notice it's just getting the weather async. Now we have our real weather service. The real weather service is just going to do a simulated call. So there's a delay and then it's going to return a string. You could definitely tie this to a regular service if you wanted. And then in this case, we have our remote weather proxy. And so with the proxy, we pass it to a URL. You can see it's going to do the get weather, and it's going to ensure the status code and work that way. So then what does this look like? So if I go to my program.cs and I want to actually call the weather proxy. So this particular demo does make a call to the API weather.gov points. It uses a GPS coordinate. And so we have our GPS coordinate already in there, but you'll see here that it's using the proxy. Yes, Bhavesh.
I can only see the presentation still. I can't see Visual Studio. Or
You can't see Visual Studio.
no.
Hmm. Let's see. How does that look?
That is Visual Studio. Thank you very much.
Much better. Thank you. Okay. So let me show you this again then. I have the iWeather service. Again, this is what I show in the class diagram in the slide, the get weather async. And then we have real weather. So that implements our iWeather service. Our proxy is actually going to take care of making the call. So our proxy's got the HTTP client. For this particular API, we have to use a header. And so I just have a sample header. It doesn't have to be anything fancy, which is good for demo code. But then our get weather async, we have the URL and how we're going to call it. Now, if I look at my program.cs, so our program.cs is going to call the actual weather service, passing in the GPS coordinates that we're feeding it. Just so you can see how this works, I'm going to set this one as my startup project. And we're going to go ahead and run it. So this is going to use the weather service, but when it uses the weather service, it's going to use the remote proxy. And I'll bring my output out so you can see. So this is going and getting our weather for these GPS coordinates, which happen to be here in Kent, Ohio. So with this demo, you can change GPS coordinates to whatever you are using, where you're located. We just have it for our current location. So remote proxy, what this allows us to do, this allows us to handle the calls to remote servers if needed. All right. Of course, I have the code on the slides, but I would rather we do the code demos if the code's going to cooperate. So key things to note for remote proxies. So there's the location transparency. They provide the local representative, and they make the remote interactions appear as local ones. They can handle that network communication, the connection setup, request response, and error handling, which is nice to deal with. Marshalling and unmarshalling. So some people may not be familiar with the terms, so I want to make sure we define those. Marshalling is when you're doing transmission over a network, and then converting to the original form, that's your unmarshalling. With remote proxies, they can also include security mechanisms, so encryption and authentication authorization, things like that. And then they're also used for performance to make things a little bit easier. So that's remote. The next proxy I want to make sure we talk about is our virtual proxies. So virtual proxies, what these are used for is that they allow us to get access to resources that are expensive to load or create. Expensive, be it in cost, expensive in time, whatever we determine as the expense, the expensive part, we might want to try to lower that cost. So how do we do that? We only load our stuff when we need it. And when I say stuff, I want to talk about probably things like images or other documentation, for example. If they're heavy files, then you want a virtual proxy to help with that. This could also improve your performance and reduce your memory usage. All right, so where do we see virtual proxies? So virtual proxies are used for things like lazy initialization. So you can delay your creation and loading of those objects until they're needed. So lazy as opposed to eager loading. And then resource management. So making sure you have your resources there and you're not getting super memory intensive stuff being created over and over and over again. There's the on-demand loading. Again, that whole going back to only loading it when you need it. This is super useful for UI. And the reason why I stress super useful is when I think of UI and heavy UI loads, there's still that user experience component that we have to keep in mind. And so using a virtual proxy will allow us to control better the loading of those heavy objects. All right, so our sample for the virtual proxy is that we're going to have this image. We want to display the image. We'll have a real image, pass it its file name at the display. Notice we'll have something for loading the image from disk. Now the client's going to want access to the real image, but we'll get it through the virtual proxy. I'll show you what that looks like. Let's drop over to Visual Studio. All right. So you should see Visual Studio, correct?
Yep.
Awesome. All right, so this one is the virtual proxy. So we'll set that one as our startup. I'm going to close all these because we don't need those open. And let's look at what we have. So you'll notice that these projects all follow the same pattern. Again, going back to that initial slide of there's the common pattern of there's an interface. So there's an interfaces folder with the interface. And then we have its implementation outside of the interfaces folder. We have our virtual proxy or our whatever proxy type it is. And then we have our program CS. Again, our image, as we showed in our class diagram, just shows display. But with real image, so now real image, we kind of need things like the file name, where is it coming from? In this case, with the demo code, you're going to see some thread sleeps to simulate the time it would take for something to happen, but you could replace this with your own code for actually loading the heavy resources. And then you can see that this will say, okay, it's loading something, and this is what it looks like. Now, this is just going to load the image from disk. Let's look at our virtual image proxy and what's going on in there. So the virtual image proxy is going to look at the real image, and it's going to have also that file name because that's what the real image needs. And then its display will check to see, all right, does that image even exist? If not, let's create it, and then let's display it. Now, if it exists, it's just going to display it. So that virtual proxy is going to handle that part. Our program.cs, we could feed it some names. And then you'll see things like, oh, it's created, but we haven't loaded it yet. And then we can call display and it'll be loaded on demand. So what does this look like? So I'm going to run our virtual proxy demo so you can see. And we'll bring that over. So what we had going on here is you can see the images are created but not loaded. And then when it's called loading, you'll see that it shows it. So there was delay. And actually, if I rerun it, you can see that delay. Like I said, with the virtual proxy, if you want to implement it in your own code, take the thread sleeps out and actually put the loading in. All right, so we've looked at the virtual proxy and the remote proxy. Let's look at a couple others. Again, virtual image proxy, there's the code we talked about with the virtual proxies. So think of those as on-demand loading. I commonly will use images as the example because images tend to be the large thing. This also could be audio, this could be video, this could be other files that you have, zip files, things like that. So that's an on-demand loading where you would have that in place. When you want improved responsiveness, virtual proxies can help with that initial loading time. Again, with the proxy patterns, you're going to see that transparency where it works with the proxy in the same way it would interact with the object itself, but the proxy handles a bunch of other things in its process and its implementation. Virtual proxies, think of them as they encapsulate that logic for the deferred loading and resource management. So the real subject, like how it does its implementation of loading, is still clean. You're not changing the original code. That's what I like about all these proxies is that it allows you to add on functionality to something already without having to touch the base code. All right, next up is cache proxies. Caching, again, makes it a little bit easier for us to save things and then reload them from the cache rather than taking expensive calls or expensive operations. This is good for reducing database calls or API calls. You can cache those responses. If you have intense calculations, there's also that. The key things to note with caching is that you have to keep an eye on the cache expiration and setting it within a reasonable tolerance for whatever your application needs. So data caching is a common thing that you'll see, where you have a real data provider that'll get the data, but then you have a cache proxy that will store that data for X amount of time. All right, let's go back into Visual Studio. And we're going to look at our cache proxy. So cache proxy, set that as our startup. We have our iData provider. And so that'll get our data. Close all the tabs. And then we have a real data provider. So get data is going to get data for whatever you're passing in. Again, thread sleep for the emulation of, hey, we're doing something here, but you would replace that with whatever code you need. Now the cache proxy, what does that look like? So our cache proxy right now, we have it implementing, this is just in memory in a dictionary, but you could set this to do something like Redis or another type of cache as well. For our memory caching, what you can see, so I've got that dictionary string, it could be string object, it could be whatever you're storing. But then get the data, and you'll see, okay, if it exists, then just let's return the thing. Otherwise, we need to get the data, and then we add it to the cache, and then we return the data. So we're going to first time check to see, is it there? And if it's not there, then we're going to add it to the cache. Now, the next time we get that item, we'll check to see, is it in the cache? It's in the cache. We'll get it straight from the cache. We're not going to have to go back and run another query to the source. Again, keep in mind with caching, you also want to set the expiration and maintain that expiration. In this particular demo, there's no expiration, but problem with caches without expiration is you don't necessarily know how valid your data is. And so it could be one of those where you have the data cached for a long period of time. And it has since changed, but you wouldn't know because you're like, oh, is this data in the cache? Yeah, it is. Okay, we'll continue to use what's in the cache. So again, when you're implementing caches in the for real part of it, make sure that you also include cache expiration. So this is what it looks like for our code. And if we go ahead and run our cache proxy demo, and bring my output here, I'll rerun it so that it's on the screen. So you can see for the first time around, it shows the data. And then for the second time, it's coming from the cache. That's what's going on with the cache proxy. So with the cache proxy, things to note for that. We'll close it. Again, there's our cache proxy code. All right, so with cache proxies, this is where we've got the performance improvements in that we're not making expensive calls to get these large objects every single time. We just store them somewhere in our cache, wherever our cache is held. So you might have an in-memory implementation. You may have a caching store such as Redis, someplace where you would store your cache in general, and then notice that, okay, if it's in the cache, we'll use it. Again, the same transparency we're seeing with all the proxy patterns where you're interacting with the proxy similarly to acting with the real object. But this is where I have to stress the importance of caching is that you also need to make sure that you have valid data and not stale data. So that's when you need to look at things like time-based, event-based, conditional, just making sure, okay, given this situation, is this data still valid? Memory management is also key, especially if you're doing something like an in-memory implementation. So just be aware of that. With the cache proxies, again, the consistency is helpful, but understand that if you're caching your data, the live data still can change, and your cache data may not necessarily match the live data. So you might want to see what you can do about that with, again, in terms of data consistency and cache invalidation. All right, next up, smart proxies. All right, so what do we know about smart proxies? So what they allow us to do is we get to add additional behavior to the objects that they represent. So where do we see this? I'm going to take a good guess of authorization and authentication, access control is probably the #1 use I've seen. I've seen this used a lot. Resource management, so making sure resources are properly allocated and being used by the right people. Adding logging and monitoring, smart proxies, I have seen it with aspect-oriented programming or the cross-cutting concerns. I've seen smart proxies used to help in implementing that. Performance optimization, so again, you're going to see caching can fit in there sometimes. Your smart proxy basically is you're going to have some kind of functionality you need to add. In this case, the demo is going to show we're going to add access control, we're going to add logging as well. So let's say you need to do an audit around how things are being used with an object, then maybe you need a proxy to do the logging around it. Let's go look at the code. All right. So our cache proxy, we don't need that one. Now we want to do smart. I'm going to close that and close that. Let's say smart. So we have our iDatabase. And it just has a, let's execute a query. And you'll see here that it's going to say executing query, and then you can call to a real database. Now the database proxy, what this allows us to do is it allows us to say, okay, who's accessing this? Do they actually have access to this? If so, then let's log that the query is happening and then run the query. I'll zoom it in so you can see that a little bit better. So you can execute that query. Or you can check to see. So in this case, it's just, is this person an admin? And then if so, yeah, they can run it. When it comes to logging the query, again, this is good from an accountability standpoint, from an audit trail standpoint, the who did what in the system, when and where. That's why I love logging. In this particular case, there's not much going on, but you can see. So in our program CS, when we call to that proxy, we're just going to run a couple queries. We're not going to hit a database because we didn't wire up the demo part of it to talk to a database, but you can extrapolate from the code there. Now the real database, again, this is the implementation of the thing that I need to be able to deal with. The database proxy is going to wrap around that real database. So you can see real database. And then this particular case, I'm going to pass in the role for the user. So when I run select start from users as admin, that should be good to go because the proxy logic showed if the user's admin, then we can go ahead. If the admin role is, or if it's not an admin role, they can't run this query. So we're going to run those. So this again is authorization at a high level. You can definitely wrap this with your own authorization code. And I'm going to run it again, this time on the screen so you can see logging the query, executing the query, access denied. If we wanted to make it more useful, we could go into our logging part of our proxy. And then you could say maybe string role. And something like run by, maybe pipe it, role. And for my log query, there's query and my user role. That way you can see, okay, what role is trying to run queries. But notice executing query, select start from users, access denied, insufficient permissions. So we never actually hit that part. with the log query. If we wanted to log the attempts, then we could bring the log query logic in. So again, this whole smart proxy, what this allows us to do is we can add this logic around our database. In this case, for example, adding the access check, and then, okay, if they have access, do things. So that's the smart proxy. Again, it allows us to add more functionality outside of the object without having to touch that object. So with the smart proxies, the check access method in our database proxy is checking to make sure that only the particular roles that we approve of will run those queries. For logging, again, this allows us to add logging outside. So our objects may not necessarily have the logging that we want or need, especially if we're trying to deal with, for example, a production fire. And you've got a production fire in a very undocumented area. Okay, now how do we get logging in there? This could be a way you do it. And then with the encapsulation in smart proxies, so you add that functionality without touching the object itself. All right, so we've talked about remote and virtual and smart and cache proxies. Now we're going to talk about synchronization proxies. Synchronization proxies are a little more complex, for a lack of a better term. And that's just because they're used in concurrency situations. So when it comes to the synchronization proxies, what they allow us to do is allow us to ensure that the object is actually accessed in a safe way with multiple concurrent threads. And our operations are going to be performed atomically with synchronization proxies, or you can set it to only one thread at a time accesses the object. So if you're dealing with concurrent threads accessing an object, synchronization proxies could come into play for that. Dealing with thread safety is important in those cases, and so sync proxies can handle those. The atomic operation, so again, guaranteeing the atomic operations itself, making sure they truly are atomic in a concurrent situation. Again, maintaining consistency with the object in a concurrent state. So if something's getting changed, how does that get handled? Sync proxies and the logic within the sync proxy can handle that part. And then if you're sharing resources in a concurrent environment. So concurrency is a challenge. Sync proxies are there to help make it easier. Excuse me. Okay. So we're looking at the concurrency counter. For this demo, we have an I counter that's going to keep a value, and then we'll get that value. And then the actual implementation. The client is going to want to know how to get that counter's value. And so we'll take a look at that with the synchronization proxy. All right, let's go into Visual Studio. And in this case, we don't want Smart Proxy, we want our sync proxy. So set that as our startup project. Close these. All right, so with our sync proxy, again, this is our interface. The implementation, we have our private counter, we have the get value and the increment, so pretty standard basic logic. And with our sync proxy, again, we're going to deal with some threads here. So this is where we get into our lock object. And then, okay, well, what's going on with the lock object? So we have this counter that we've injected into the constructor. And then we have our get value and increment, and then there's this locking logic. So then we can get our value and we can increment it. Notice that the locking is handled within the proxy itself. So this is not within the counter. The counter doesn't know anything about thread safety at all. But we need to take care of this. Don't say that. So this is why we have that sync proxy there. So now what does this look like in the implementation? So let's look at our program.cs. So we have our counter. This is our real counter. We have our proxy where we pass in the real counter. We're going to create some threads. And our threads are going to do some incrementing. And we'll start our threads and you'll see the join and then the final count. And so you can see how this is working. If it helps at all, we can add some more. So this is, I'll do a console.writeLine. This is thread 1 incremented. And we'll put thread 2 incremented here. Just so that you have some idea of how the code is getting executed. And then if I go ahead and run our sync proxy demo, and notice this is for 1,000, so it's going to go by pretty quickly, but better yet, $sign that, and $sign this, and I'll put the I in there, just so you can see how that goes. And then we'll run it. I bring it in here. So you can see there's our thread 1s. Hold on. Console.readline. Let's not dismiss that yet. Try that again. So that we can see it here. I can scroll up a bit. Scroll bar. So you can see we've got some, I'll zoom in a bit more so you can see we have some thread 2s and thread 1s. Notice that they have their different numbers. But you can see which one's incremented which because we added the logging in there. And then you can see that its final count is 2,000. That 2,000 comes from each of those threads going to 1,000. So that's what the sync proxy handles. Again, that sync proxy's got that locking handled within it. So we can't add it within the counter. I mean, sure, we could if we wanted to guarantee it, but maybe that counter is used for something else and thread safety isn't as important. Then just give me the counter to do the things. Thread safety we can add after the fact, thanks to synchronization proxies. All right, so we looked at that. So when it comes to the synchronization proxies, things to note are that you'll see them in concurrent situations when there are multi-threads accessing one object. It can help with your thread safety. Now, there are 5 key takeaways to know when it comes to the proxy pattern in general. So first of all, think of the separation of concerns. If you haven't seen these images before, back in the past, there was a software craftsmanship calendar that NibblePros did. Some of these images come from that. And some of these images come from our website, deviq.com, that talks about our various concepts as well. When it comes to the proxy pattern and separation of concerns, think of it as the proxy pattern has specific functionalities like caching or synchronization, remote access, or even deferred loading. But you can do this without changing the interface of the underlying object. So then you have the separation of their primary object's responsibilities. You have the core responsibilities within the object itself. And these additional concerns are handled by the specific type of proxy. So again, with synchronization proxies, that's where you work with the thread safety, for example. Or if you have really large images, then you go with the virtual proxy and deferred loading. So encapsulation is another key takeaway. So think of the proxy as it's the intermediary for the real object. You can still access the real object and make the calls, but when you make the call through the proxy has that additional logic that handles some of the details that the inner object doesn't need to know about. You're going to see with the proxies that they hide the implementation details of that real object. Client doesn't really need to know what the object's doing either. Virtual proxy, that client doesn't know that the object creation is being deferred. It doesn't need to know that though either. The proxy will handle the instantiation of that real object when necessary, only dealing with it when we need it on demand. But that detail is encapsulated. All right, when it comes to improved performance and efficiency, There are different types of proxies that can help with improving the performance and efficiency of the system. Those include the virtual proxies. Virtual proxies, remember, they delay the creation or the loading of expensive objects until they are actually needed. So you're going to reduce the initial load times and memory usage. These are things that are loading on demand. The other ones that we use for improved performance and efficiency are cache proxies. The difference on this one is a cache proxy will check to see, does this exist in a cache? If it doesn't, do the real call and then store that in the cache. If it does exist in the cache, then just load the cached object. Keeping in mind when you're dealing with the cache proxy, you still need to make sure that you have logic in there to prevent from data getting too stale. Another takeaway with the proxy pattern is the enhanced control and security. So there are different proxies that can also help add layers of control and security to the objects. And these include things like our remote proxies. So when you're making calls to APIs, for example, or calling to remote endpoints within a distributed system. And then smart proxies, you can add access control and logging and other pre-processing or post-processing tasks to protect that real object and log its usage and access. And then when it comes to concurrency management, that's where synchronization proxies come into play. So this is, again, what allows you to manage those objects that are getting accessed in a concurrent situation. Multiple threads are involved, making sure that you're preserving the consistency across the whole situation, and then also trying to prevent race conditions, and then you're ensuring your data integrity. So today we took a look at 5 different types of the proxy pattern and how you can use these to add more functionality to an object without actually touching the object. Any questions about the proxies? As I mentioned, there is a GitHub repo that we have available. It's going to be github.com/NimblePros. It's going to be our proxy patterns demo. I will include a link to that in our thank you email. So at the end of this, once the recording is done, I will get this in a spot where we can send an email where you have access to the recording on Zoom. It stays on Zoom for about 30 days, and then we move it to our YouTube channel. But that'll get you access to both this recording as well as the GitHub repo and additional links to supporting materials as well. If you have any other questions, those thank you emails, if you reply directly to those responses come over to me. So rest assured that those thank you emails, there's a person on the other side. And I will gladly do what I can to answer questions and connect you where needed. If you need anything when it comes to dev training or incorporating DDD practices, clean architecture, event storming, .NET 8, software architecture, Arcadas, any of these things, feel free to reach out to us. Bit.ly, so bit.ly/contact-mp, so contact Nimble Pros. We've got our QR code if it's easier for you to scan it. But if you have any questions, please feel free to reach out. And thank you all for coming today.
You have a good one.
Take care.
Thanks, Sarah.
Thanks,